Welcome back, students. Myself Sir Sunil, your physics teacher. Good morning to one and all. How are you? I hope you all are fine and also you are enjoying the holidays. Okay. So we have already started our chapter motion and 2-3 days are over and we are discussing different kinds of motion. And today we are going to discuss one important topic from this chapter, that is mixed motion. All of you please take out your book and ready to watch the video carefully. Okay students, 7 types of motions we have discussed. In 2 days we are discussing different types of motion. Clear? And today we are going to take one important portion from this chapter, that is, I told you, mixed motion. Okay. Sometimes a body can move or body can have more than one type of motion simultaneously. Clear? A body can have more than one type of motion simultaneously. Such a motion is called a mixed motion. Examples: the wheels of a moving vehicle such as cycle, car, train, etc. You just observe the wheels of a moving vehicle, okay, and observe how many types of motion can be seen there. Here we can see, we can observe both translatory as well as rotatory motions as it moves from position A to B while rotating. See, here is the diagram, you just observe. Clear? The tire itself rotating, rotating its own axis. So we can say that that is rotatory motion. That is rotatory motion. And while moving the tire, it moves straight, it moves forward, that is a translatory motion. So the movement of a moving vehicle's tire shows both rotatory and translatory motions while it moves from A to B, position A to B. Another one example, a drill used by a carpenter maybe you have seen clear drilling machine. Did you observe any time the movement of a drilling machine? A drill used by a carpenter has both rotatory as well as translatory motions. You just observe the tip of the drilling machine. It rotates fast, and it moves ahead inside the wood while rotating. And also, if we observe the movement of the tip, it moves inside the hole. It moves inside the wood while rotating. So we can say that in a drill there are 2 types of motions. First one, it is the tip moves in a rotatory motion and it moves straight inside the wood. That means it shows the translatory motion. So it can have a drilling machine can have 2 types of motions, rotatory and translatory motions. Here we can see the diagram. See, translatory and rotatory motions of a drill used by a carpenter. And next one, a carpenter's saw has translatory as well as oscillatory motions. A carpenter's saw has translatory as well as oscillatory motion as it moves down while oscillating. Another one, a ball rolling on a ground has rotatory motion as well as transitory motion. Okay, a ball rolling on the ground, ball itself rotating and it moves straight. So we can say that a moving ball have two types of motions, rotatory as well as translatory motion. And also the earth rotates about its axis. The earth rotates about its axis and at the same time it revolves around the sun in a curved path in a fixed time. Okay. Here also we can have two types of motion. One is rotatory motion, another one periodic motion, means fixed time. Clear? Or curvilinear motion or circular motion we can see. Different types of motion the movement of earth shows us. Activity 3. Some examples of motion are given in the table ahead. Identify the types of motion. Here it's a holiday homework for you. Okay, you just write which type of motion it shows. Many events are shown here in this side. Okay, in right side examples of motions are given here, and you please write here which type of motion. It's a holiday homework for you. Okay, students, and complete and keep. When the school starts, I will check. Now activity 4. Each group of 4 students of the class should sit together and list at least 10 objects in motion and state the type or types of motion of each object in a tabulated form as given above in activity 3. This is also one activity for homework. Clear? Each group of 4 students of the class, this can be done in the class only, so we will do in the class. Okay. Now we are going to discuss about speed, the portion speed. In chapter 1 we have read that the speed of a moving body is the quantity which tells how fast or slow is the motion of the body. Speed tells us how fast or slow a particular body. All vehicles such as scooter, car, bus, etc. are provided with a speedometer to indicate the speed of the vehicle at any instant. Clear? You might have seen in scooter nowadays digital speedometer is there in each and every vehicles. Okay. Anyway, it shows the speed, how fast the vehicle, how fast the particular vehicle is moving. Clear? And the speed of a moving body is defined as the distance travelled by the body in unit time. So we can write the formula here to find out the speed, that is speed v is equal to distance travelled upon time taken. That means d upon t, distance upon time. The SI unit of speed is meter per second. The SI unit of speed, that is meter per second. The symbol is this one, meter per second. The other commonly used unit is for speed, that is kilometer per hour. Symbol is kilometer per hour, this one it is. And where 1 meter per second is equal to 3.6 kilometer per hour, or 18 kilometer per hour is equal to 5 meter per second. So what is the SI unit of speed? Meter per second. And the bigger unit is kilometer per hour. Okay, students. Now we are moving to another topic, uniform motion. That is uniform motion. What is the definition of a uniform motion and the examples we are going to discuss now. If a body travels if a body travels equal distances in equal intervals of time, then we can say that that motion is uniform motion. If a moving body travels equal distances in equal intervals of time, then that motion is uniform motion. Thus, for a uniform motion, the speed of the moving body remains constant. The speed of the moving body should be constant. Example, the table given below shows the position of a moving car at a different instance. Clear? At 9 o'clock, the body is at rest, means 0. And 10 a.m., that car moves 30 kilometers. 9 to 10, 1 hour. In 1 hour, clear? This car covered 30 kilometers. Then 10 to 11, again 1 hour, okay? 1 hour. 10 to 11, the car covered 60 kilometers. You see, in between 30 and 60, what is the difference? 30 kilometers, okay? And 11 to 12, the car reached or covered 90 kilometers. Clear? 90 kilometers. And from the above table, we can find the distance travelled by the car and the time taken to travel that distance. This is given below. From 9 a.m. to 10 a.m., it took 1 hour. Clear? Distance travelled, that is 30 kilometers. 10 a.m. to 11 a.m., there is also same time, 1 hour. Distance covered also same, 30 kilometers. Then 11 a.m. to 12 noon, 1 hour is taken and distance covered is 30 kilometers. Time, in time we can see that 1 hour. In between 1 hour, the car covers 30 kilometers. Okay, it shows that, clear? It shows the distance travelled by the car in an interval each of 1 hour. So, from the table above, it is clear that the car has travelled a distance of 30 kilometers in each 1 hour. So, the motion of the car is uniform with a constant speed 30 upon 1 hour, that is equal to 30 kilometers per hour. Per hour, that particular car that moves 30 kilometers. Clear? So, this car is in a uniform motion. Car is in a uniform motion. Okay, students? Now, one important fact, do you know, in a clock, the second arm moves in a circular path with a constant speed. So, its motion is also uniform. In a clock, the second arm moves in a circular path with a constant speed. So, this is also an example of uniform motion. Now, we are going to discuss one more type of motion, that is non-uniform motion. Non-uniform motion. The definition is, if a moving body travels unequal distance in equal intervals of time. If a body moves or travels unequal distance in equal intervals of time, then this motion is non-uniform. Example, figure 2.18 shows the position of a car at a different time instance. Clear? Here we can see 9 a.m. to 10 a.m. How much kilometer is covered? 4 kilometers. And 10 to 11, How much kilometer is covered by this car? 8 kilometer. Then 11 to 12, how much kilometer is covered? 3 kilometer. See, 4, 8 and 3. 4, 8 and 3. Different kilometers are covering in equal intervals of time. This particular car. Not like that, the first example. Okay. So, we can say that this car is in a non-uniform motion. When it starts and then travels to its destination, the car is initially at rest at 9 am. Now it starts moving slowly, then it picks up speed and moves at a constant speed. When it is near its destination, it slows down and then comes to a stop at 12 noon. The car travels 4 kilometers in the first hour. Okay, we have seen the diagram. Okay, then the car travels 4 kilometers first hour, then 8 kilometers in the second hour and 3 kilometers in the last hour. Thus, we can say that the car does not travel equal distances in equal intervals of time. So, the motion of the car is non-uniform. And similarly, while cycling, you must have experienced that you have to move your bicycle very slowly when you go through a busy market. In busy market, suppose you are riding the bicycle in a busy market, what you will feel? You have to move very slowly. But as you get a clear road, what you will do? You will increase the speed. Means you will ride fast. Thus, the motion of your bicycle is uniform motion. Is in non-uniform. Sorry, the motion of your bicycle is in non-uniform. In cases when bodies move with non-uniform speed, we specify their average speed. How can we find out the average speed of the body? When the body is in a non-uniform. So students, it's time to wind up our today's class, today's session. Okay, tomorrow we'll start with average speed. Till then, goodbye and have a nice day.